I've had a hell of a week. I was up till 1 a.m. finishing this after taking my son to an open high school last night. We were one of like about 2,000 people who showed up to try and get into the school. I had a meeting downtown in the middle of Salesforce. Had shut down the cafe where I was having an important client meeting because they had a pop-up event there or something. And I had went to the dentist this morning just to round it out. So the one thing I can guarantee is this talk is not exactly 50 minutes long. I will do the best to keep it sort of roughly there, but you can help me actually probably just by getting me completely off track, asking random questions anytime you feel like it, and derailing this, and we can go anywhere you like. I'm a big fan of sort of giving the answers so that if you just want to walk away and get the take home, you can get it in 60 seconds. It's okay to use full stack FSharp. And I'm not, I'll give caveats on that, but I'm not a casual evangelist. I don't run out and I actually clock myself. I take on a new programming language roughly every 10 years. That's about my cadence. So I'm 2 years over the line for FSharp. I probably should be abandoning it. I adopted Python in 1993 and everybody gave me shit for it because nobody thought Python had a future. And now the Python people are giving me shit for FSharp because, you can't stand in the way of Python. I've had the luxury of just being able to do whatever I damn well please for a while. And if that's sort of testimony enough, then, I'm happy using FSharp. I could use anything I wanted. But lots of caveats on that. So I'm going to try and deliver on what I've promised here. I actually took a screenshot of this months ago just so I'd remember what I was doing. And then I was absolutely convinced I was talking yesterday at midday. And then the night before, I was like Kelvin, when my homework was due, I was really pleasantly surprised to find out I was talking on Friday. And I thought I was going crazy, and then Gen said, oh, actually that's an old screenshot. We did move your talk just to mess with you. Okay, I work for Demetrics. I'll talk a little bit about what we're doing. That's where you can find me. There is 70 slides in this deck. I absolutely guarantee you won't see the content on all of them. So if you've got any questions later, I'd be happy to just talk about anything. It's the most important slide. I think the thing I I've always known this, but I really came to appreciate in 2018 is the best thing about the FSharp world is the community. And we got help, this sort of like roadside assistance from so many people this year. And I'm absolutely certain that I missed a handful of them. But a lot of these are really like late night Twitter sessions or chats on Slack or something, occasionally calls with vendors, and some really strange, like we were deep down inside Postgres in the middle of the year, and the Postgres community helped us out. And it's actually the other thing, I feel kind of lazy living on the West Coast. I think Yen, who introduced me, also works with us. And she made the observation that Europe has a lot of really good FSharp people. And often they're contributing open source. And the West Coast has a lot of great FSharp companies. And she feels like Europe is sort of being taken advantage of. But often we could get overnight support. We could, post an error and somebody's actually fixed it or talking to us late night in the UK or something. So. Okay, this is my philosophy on new technology. It's downhill in every single direction in a bad way. You're kind of optimal where you're standing right now, and these hills could be tabs, spaces, Linux, Mac, FSharp, Python. Everybody's sort of optimized for productivity with what they're doing. So anytime you change your tool stack or anything like that, you're taking a big risk. And if you're using JavaScript and you're happy with it, why would you use Fable, for example? So I'm going to convince you maybe to change what you're doing, and you should be really careful because everybody's pushing Kool-Aid. So I'm on a soapbox, take everything with a grain of salt or a grain of Kool-Aid or whatever. And just remember context. I'm going to explain why we do what we're doing and why it matters for us. It may not be relevant. If you're trying to serve 1 million customers a second or something, this may not be the best stack for you, or it might be. I'm going to give you a crash course on genetic engineering because that's what you really showed up. It's very easy when you work in computational biology to do really cool, sexy talks about really exciting kind of gene stuff. And that's what I did last year. And that was fun. We talked about a DNA compiler. And when I talked about what I was going to talk about this year with Matthias, he's like, don't you want to talk about DNA engineering? That sounds kind of way cooler. And I think what I really wanted to do this year was give you a boring talk in the sense that a lot of stuff we do is very mundane. It wouldn't be out of place, running a factory or something, running a cafe.
but that is actually an enormous amount of what we do is actually relatively routine stuff. And I want to explain why, sort of in a web context, FSharp is just as good for building web apps as it is for building DNA compilers, I guess is the take-home message. I think for a long time, mainly due to Microsoft, FSharp had a reputation as, well, if you're doing something important, really complicated, use FSharp, otherwise you can just use anything and you'll be fine. So I want to debunk that. Okay, we're well over 1 minute into genetic engineering. So what we do is take stuff that you would normally get out of plants, so I think medicines or stuff that you might chop down a forest to get a small amount of some kind of plant. And we move those genes into yeast. It's the exact same yeast you would use to make beer or wine or bread or whatever you're making at home. And then basically by migrating those genes, sticking in a fermenter, exactly the same way you'd make beer, you can make that compound. And the idea is that if a plant is making something in very small quantities and you need a lot of plant to make a little bit of compound, it's going to be way more efficient to just ferment it. So it's pretty simple. And one of the pioneering projects was done at my old company, which is Malaria Medicine. The world's best malaria medicine comes from Chinese wormwood. They make hundreds of thousands of tons of that plant every year to make a relatively small amount of medicine. And so there's some elegant work to move those genes into a plant. We're working on different compounds, but anything basically where you see someone growing a lot of plant to make a little bit of something, in theory this technology will work. Convince you all to become metabolic engineering. Metabolic engineering is really easy. That chart up the this guy's a metabolic engineer, I can tell. Actually, these are two of my former colleagues from Amyris. If you're looking for opportunities in biotech, they're probably hiring, you should chat with them. There's actually a really famous chart out there that has all the reactions that occur in a typical cell, and I've put a little bit of it at the top there, and then a little bit down the bottom. And it really is quite simple. So basically right now, if you've eaten anything and not planning on dying, you are converting something like that into something like that. And there's basically a little enzyme in there that's doing it, which is just a giant, tiny machine. And that machine is entirely specified in binary. It's basically a small part of the genome will have a little bit of DNA sequence that specifies it. And way long time before your ancestors were even climbing out of trees, yeast had a patch process that looks a little bit like git merge. It can basically take, you laugh, but it's basically the same thing. So it's a context diff. If you have some upstream and some downstream DNA that matches some bit of the binary, and then some new stuff in the middle here that you want to stick in, yeast will just happily, under the right circumstances, merge that piece of DNA in. I showed this, I had my 12-year-old son QC my slides this morning. He says, "Daddy, that is the coolest slide." So you know how to impress a 12-year-old. Okay, the things you should know about biotech software development. Most people aren't happy with the software they're using. I can make a lot of money. I could be busy for the rest of my career unfucking up people's software stacks in biotech. This guy's laugh because I abandoned them with some of my legacy code. Left a whole bunch of FSharp and then moved on to a new job. It's a good way to get people adopting. It's a very complex domain. I think it's actually a very good, in some ways it's a very good test bed for software because problems we deal with are complicated. It matters. If you get your software, if you do software well or badly, that can be the difference between happy biologists or not getting the job done. It's a mixture, as I said, of these really exotic, like let's go and build a DNA compiler or predict the melting temperature of a piece of DNA, and where in the freezer is that sample we processed last week? And it's actually mostly mundane. It's these two complicated fields, so you've got a bunch of computer scientists who don't speak biology, a bunch of biologists who don't speak computing. Rapidly evolving requirements is code for users change their mind frequently and didn't actually tell you what they needed the first time you asked them. If you're working at a company, a traditional sort of Bay Area software development shop, you may have 5 or 10 people supporting one application. We're more likely to have 5 applications supported by one poor person. So it really is a test of the efficiency of your stack. We do know who our users are. They're very close by. We can talk to them a lot, sometimes too much. And I wouldn't say we have a big data problem usually, it's just messy data. So people who are pushing giant map-reduced solutions for biology are probably dealing with the wrong problem. It's far more likely that 100,000 rows into some data file, somebody spelled something differently, or there's 10 columns instead of 8 because somebody was editing a spreadsheet. There are a few things that make a lot of data. And I said this last year, I'm not FSharp for life. If there's a better tool out there,
I will switch. I'll get down off my hill. I'll climb. You know, if I was programming drivers all day long, I'd probably be using Rust or something. But for the stuff I do, this is my shopping list. If there's a better language out there, it has to hit most of these requirements. You're not going to give me curly braces back. I don't want to give up units of measure, and it doesn't seem anybody else has discovered that joy yet. Parallelism has to work. You have to have mature tooling. That one's hard. I'll wait a little bit for tooling. But you see some of the other functional communities out there that are desperate. You know, I see complaints on Twitter like, well, VS Code doesn't do this thing that Visual Studio does, or Visual Studio doesn't. We're complaining about parity between our two best editors in the community. We are really spoiled. There are communities out there that are desperate for any editor that will work with their programming language, let alone IntelliSense. And we hang out with nice people. That's absolutely a requirement. So we kind of made a bet a year ago, and I'm server-side, like I control the server, it's a tame environment, do everything you can on the server side, but I had to admit the reality is that more and more stuff is actually happening interactively on the client, and I've got to deal with JavaScript. And so I think probably the biggest challenge for us was, really, is Fable actually ready for the kind of stuff we're doing? And so I talked to people. Afonso seemed like a nice guy. Sure, we'll give it a try. And if it goes badly, we'll be rendering server-side HTML probably pretty quickly. There were a lot of choices to make, and this is basically where we ended up with, but it's full stack FSharp. I'll talk a little bit about Fable later, but Fable's one of those things where I still don't really believe it works, but it does. The nicest thing I can say about it is a year later, I have not looked at a single line of JavaScript that it's emitted, and I've never had a problem with it. Closest I've ever come to having an issue with Fable was that my bad code was reading out of bounds in an array, and when the .NET runtime on the command line would just slap you down, JavaScript ran one step further, retrieved a null, and then slapped me down. So it was a little bit of difference between back end and front end. We've tried out 2 clouds, and I'll talk about that a little bit later. And typically on the client side, we have users running around the lab with mobile devices or robots and things like that, talking to our data servers. Everything's rendered client side. We have another platform. This is the really cool, sexy bit of biotech. We get to do really, really interesting, kind of colorful, exciting things. That's a test run on a robot. So basically, each one of these little things is a well, and we're looking at it from underneath. And there's basically a tiny bit of liquid in each of them. And it really is just fancy French cooking. It's not throwing a stew together. You've got to be a little bit careful about the ingredients. Precision matters, so it's definitely French cooking, but it's not that much more complicated than it. We're just following a recipe, and it's tedious. And there are people who go and get a biology degree, and they basically spend 10 years of their life training on moving a little bit of liquid really reliably between 2 locations. And humans make about a 1 in 200 error rate when they're moving stuff, and that's when they're doing a really good job. One of my colleagues invented, he should patent this, the movable hole. You get a piece of tape, you put a hole in it, and then you stick it down on top of the plate you're working in, and that way you can remember where you stuck the liquid, and then you move the hole. And this is the level of sophistication with people who trained at UCSF and Berkeley and Stanford. So robots are definitely a good idea. We're also increasingly moving smaller and smaller amounts of liquid. This is a robot that spits basically nanoliter-sized amounts of liquid using sound waves. So you just put 2 plates together, one on top of the other, and the sound will just come up and flick a tiny bit of liquid from place to place. And it doesn't make mistakes. When it does make a mistake, it's actually really apologetic, and it tells you that something didn't happen. And then basically our challenge is to put all of this together. So let's see if this will run. I've got pretty much a 100% track record of video failing in conference presentations. So you might wonder, why do I continue to use videos? I even crashed a projector in one talk. It's not going to play. That's really impressive. Oh well. Suffice it to say, things will move around. Let me see if I can... Blaming PowerPoint. Pointer options, pointer, pen. Let's try this. Oh, it was just about to move. No, okay. Trust me, things move around, they get picked up, they get put down, they get labeled, they get scanned, and it's a little bit tedious to program these things, but actually our primary requirement, the robot will just run itself if you give it the instructions, but our job is usually basically telling it at a high level what needs to happen. So it will say, go and find this plate in the freezer, get it out in well A6, which is a particular location, pull some stuff out, put this much liquid in, take it over there, heat it up, cool it down, spin it around. No, definitely not going to play ball. Damn. I saw one of our neighbours in the biotech incubator where I work. Oh, there we go. Haha. Basically, their entire presentation was 6 minutes of video, and that's all that failed. I felt so bad for them the next day. They sell these really cool instruments, but if you can't... Okay, there we go. What was I going to play? So there's different tiles of things going on here. This is a hotel where basically plates hang out when they're being retrieved. This guy's basically going through an inventory, finding the particular plate that it needs. This one over here looks like a Gatling gun, is actually firing little metal pins at yeast sitting down that are growing on a plate, picking them up and moving them around, putting them in liquid. The guy on the right's moving sort of larger amounts of liquid around. So again, we can pay postdocs a huge amount of money to do this, or you can buy a robot. Robot's expensive, but after a year it doesn't ask for a pay rise or anything, so it's a pretty good deal. Okay, so let's talk software. These are the types of things we have to do. So describe my talk as really a little bit like a light manufacturing environment. If you had a factory, actually one of my former colleagues used to work on custom messenger bag construction, and it's actually not that different to genetics in the sense you have these complex orders coming in, you've got to marshal resources and organize them and execute something. And this is stuff I talked about last year. We have a genetic programming language we developed. There's a paper. You can actually see last year's talk. If you think it's more interesting than this year's talk, you can go and download it. And here I've just typed in a design that came out of Amorous, my former employer. And this is 90% of the recipe for making yeast produce malaria medicine. You basically just need a few lines. And that's a high-level symbolic description. And basically our users are typing in designs like this. And then what we do is take it into this manufacturing environment. So you can... Basically, if you go back in time a little bit with biology, they'd spend about, I don't know, half an hour on the whiteboard, deciding what they were going to do, and then they could spend a month in the lab actually making it happen. With robots, actually, some of them like this, some of them don't. We actually making them spend more time thinking. Some people are like, but my job is to move liquid around, you're taking my job away, and the other people are like, ooh, this is cool. So because we're driving robots, we have just basically a lot of systems that help a different team decide how they're going to execute the DNA construction. So they need all the kinds of things you'd need if you're running a video library. Do we have that video in stock? How many people have checked it out lately? Have we run out of it? What quality is it? So the computer's going to plan out all the pieces that are needed, and then it's going to basically organize the designs, and then it's going to track all the different steps as it's executed. And then the users have questions like how even the computer will just lay out where the liquid's going to be in the wells. It tells them where to find all the bits and pieces, and occasionally they'll want to take this. If they're in a hurry, they may take it and run it in the lab. So it's got to be sort of human-friendly and also robot-friendly at the same time. And then on the back end, when we've actually built the DNA, we basically do DNA sequencing to check that we built it the way we expected to, and there's a whole lot of QC where the users typically want to visualize this kind of stuff. And again, we would previously have done all the server side, just rendered GIFs up and served it to them or something, or pings. And what the approach we've taken this year, basically with Fable, is to just send the data over. You can even send the raw DNA sequence over. And I could cut and paste the algorithms we used to run on server side, and we can just paste them into Fable instead of into the regular FSharp compiler. And these are complicated things that are chunking DNA up and comparing it, and they just ran. We didn't have to change a line of code. It was pretty impressive. This code was actually written by our CEO, who's also, when he's really bored, likes to code a little bit. He's actually a physicist, molecular biologist by training, and he wrote this viewer. So it's reasonably approachable even for people who aren't sort of professional programmers. There's more user interfaces. And
it still takes a while to get the requirements from people and sit down and write it. We're much more likely to get it right, I think, using FSharp, because we usually focus on the data structures first. If you can actually understand what a biologist is trying to do, write it on a whiteboard. And it's funny, you sort of draw the data structure up, and I've trained now enough of the biologists who are sort of computing curious and taught them enough FSharp that they'll actually be able to prototype some of the algorithms, the records, the data structures, and then they come to you and then they'll say, that's got to be an option because sometimes we don't do that. Okay, that's good. We could have implemented that and made it mandatory and then left the field blank, but you've just saved us half an hour to a day to a month by telling us that. Okay, so the rest of the talk is really just things I like. I told you it was paradise. I'm going to talk about a few things I don't like quite so much, but it's mostly been a really good year. And number one of the things I would say I like is people. As I said, we've had just incredible support from people. Everything from just, hey, you should talk to this FSharp programmer, they're really good, hire them, to you report a bug and somebody's like the next morning, they fixed it. And people are incredibly responsive. It's very rare to find anybody sort of in a really bad mood in the FSharp community. That said, there's been a few iterations to get things right. Another bet we made pretty early on was that we were just really going to move on to .NET Core. I'd say at the beginning of a year ago, it was some stuff was good, some stuff was a bit bumpy on .NET Core around the tooling. And as of about a month ago, 2-3 weeks ago, we exorcised, thanks to Don, the last sort of skeleton in the closet. There used to be this sort of workaround where you'd need a copy of Mono in your back pocket if you're on a Mac or something, or regular .NET Core, and this lovely exchange where basically this issue gets closed, and then Dimitri, works at Dimetrics, is like, I don't think you claimed victory too early. Hopefully it'll get fixed soon. And then poor Don, who was up late at night, thank you, Don, in the UK, says, I found the cause of this. It's painful. And this is going to require a painful workaround. More later tonight. I don't know if you can read this, but can you read let me actually pick it up because it's so small. It says, the variable is, if import provider method base IL method ref on stack hack, then. And that turned out to be the final step, and now we're on pure .NET Core for the type providers. And it really only affected the type provider at design time. It wasn't an issue for runtime. We've been running on .NET Core all year quite happily. So thank you. It was sort of a major block. And it was something, I'd say, a little bit obscure we were doing. We're depending on libraries that depend on libraries and things like that for Postgres. And say all of that's in really good shape. My other big discovery in 2018 was community service, and I don't know if Matthias is here, but I'm going to shout out to him. He introduced this concept of DUGNAD. I'll explain that in a second. But I think my philosophy is really recycle, reuse. I think, and I'm guilty of this as much as anybody, it's a lot easier to start a new open source project sometimes than it is to fix all the warts on an old one. And if I had sort of one magic wand, it would be to say I would like less better software, not less better software, less better software. I would kill a few things, and I don't really care what we kill, but I think we should focus on a few things that work well. And Matthias came up with this brilliant idea, which is unpaid, definitely unpaid, voluntary orchestrated community work. And there's, it's one of the Scandinavian countries, I'm not sure which one, I can't remember, maybe Denmark, but they have this annual effort basically to clean up the village. And Matthias organised his first DUGNAD in San Francisco, and basically everybody just got together and fixed shit for a day, or for half a day. And everybody had different ambitions. My ambitions were really just to try to get the Ionide project to build and to fix the docs for first-time maintainers. And I got to the point where I could build it, I fixed a few of the docs, and that was a small contribution, but anybody else using that project will find it a little bit easier. Other people had much more ambitious projects, people would just pile in, and I would show up for one of these anytime, and I think if everybody just did a little bit more maintenance, like I take better documentation rather than another version of X or something where we already have 2 or 3 good ones. Another thing I really like, FSharp data. We moved on to the 3.00 scary alpha beta pretty early on because they'd ported it to .NET Core, and it just works. It's been a very, very happy experience, and I'll give you an example. Bit of biology first. This is a human protein. You're using this right now, otherwise you'd be dead. This thing up here is just the protein sequence. I turn my pen off.
that thing up there is the protein sequence, and if you put it together in that order with the amino acids, it'll fold up into this beautiful little protein structure. And the thing in the middle is a heme group that's held by the protein, and the thing in the middle of that is an iron atom, and the thing attached to that is an electron, and that's basically what makes breathing worthwhile. You don't have this, you don't breathe, doesn't go very well. Interestingly, this is a very, very ancient protein. So one of the things we use in computational biology is called BLAST. In fact, if you just Google BLAST, you think it would bring up all sorts of things, but often one of the top hits is this computational biology tool. It's that popular. So you can actually just paste in this sequence, BLAST. Here we are blasting, let's see if I should draw it. We're blasting against just the yeast genome. And a few seconds later, you'll get a list of things like this. And one of the things in here is basically a yeast protein that's very similar to the human one. And congratulations, you're related. Turns out yeast and humans have almost the exact same protein still after a billion years. This thing's so damn important that once you get it into your operating system, you can't mess with it. Now, this is the human experience if you run this program. If you run it as a computational biologist and you're trying to process a few gigs of the output, you'll get XML. I broke up with XML a long time ago. It was just, relationship wasn't working for me. The schemas were just really complicated, obtuse. You'd have to write an enormous amount of code. Most computational biology was comma-separated values because, frankly, XML wasn't worth it. And I'll credit FSharp data and type providers with rekindling the love affair. I like XML again. And I like XML mainly because you could write a really complicated XML parser, or you could just paste some XML into the type provider, which is sort of the level of standard FSharp data gives you. So you find some XML. It has to be representative. If there's some weird stuff in some XML, you need to make sure your example's weird. And there's a lot of weird stuff in biology. But if you just paste an example in, and here, basically we're just initializing the type provider, just giving you an example. If there's any problem with your XML, you'll know immediately if there's brackets don't match and stuff like that, tags. And then basically on the FSharp side, you're just dealing with regularly constructed records. It pulls out all the fields, it even capitalizes them nicely, removes dashes, underscores, and stuff like that. And now we can actually just refer to a field rather than trying to find tags and crawl all over it. And so we had probably about 100 gig of XML in this format to process. And I guess the only catch using the type provider was that it wanted to grab all the data in memory first. This was not a really good solution for us, so we actually wrote a little bit of a wrap around it, because it's basically a whole bunch of records. We're searching with a whole lot of genes. We just wrote a wrapper just to chunk the XML into reasonable sized pieces. And then if you can see down the bottom here, so this is basically a lazy generator for your XML. And then down here, you're actually just piping it to a map operation, and this is the thing that processes one of them. And the really cool, another really happy discovery, some of the parallel libraries, and this is parallel-seq. You just put really a P in front of it, and you've got, this is the way parallelism should work. You just take your seq.map and just call it pseq, and then if you're lucky, your machine will look like this a little bit later. Basically using 926% of the CPU. This is good. Fans on if you've got a cat and your cat is sitting on top of the PC. Actually, one of my cats is a really huge fan of the parallel-seq library. And I said XML is not going away. I'd say once every few weeks, when the biologist comes to me and says, we've bought a new piece of equipment, and it has a new XML file format. And so we take some more XML, we paste it into the type provider. The best vendor was one of our robot equipment vendors who basically had turned a comma-separated value list into a giant piece of XML that was a real pain. And our head of robotics said to them, look, could you write a converter to convert it back to CSV, because this is really just abusive? And they said, sure, and they got to work on it. And a week later, they delivered a script that would rename the file from .xml to .csv. Without changing any of the content. So we wrote a type provider, pulled in the XML, converted it back to CSV. So this stuff happens regularly. CSVs are also, if you've met a biologist, you've met their Excel spreadsheet collection. And we frequently get things in comma-separated, tab-separated, all sorts of different formats. I met one biologist who wanted to get some content out of a database, and it had, I think, 800,000 records,
And the tool would allow them to export maybe 5,000 rows at a time, or a couple of thousand rows. So they spent 2 or 3 days exporting it, 2,000 at a time, and cutting it, pasting it into one Excel document, and then they brought it to us, and they had Unicode characters in there, so it was blowing up pretty badly. So the CSV provider is basically like the XML provider. Give it an example that's representative, and then you can deal with your file with whatever headers there. And FSharp is really good at dealing with, you'd like your biologist to call the column, I don't know, ID or something, and instead they say my space favorite space name for it /7/5. FSharp will just quote it and you can still deal with it. I've met people who seem to like systematically choose every column name that is a reserved word in the language. So you have a value column, you'll have a type column, you'll have a struct column or something. FSharp deals with it all. You probably heard about SafeStack. This is basically a demo project that brings together Suave, Azure, FSharp, and Elmish originally. And if you're on the fence about whether you really even want to do web programming or not, or somebody's asked you to write a UI and you're thinking of quitting, try SafeStack first. And the demo project is really basically very easy to get going. We played with it. We actually tweaked it a little bit, so we decided to use Giraffe instead of Suave for reasons I'll go into. We're using AWS and GCP instead of Azure, although Azure's a perfectly fine choice. We are still using FSharp or Fable, basically, and we've tweaked Elmish. So we're on the Gorsk Prime platform. It's not as catchy as Safe, but we've been pretty happy with it. I'm just going to go through these sort of piece by piece. Any questions so far? I've been talking at you mainly. Okay. Haven't run for lunch. Yep, that's good. Okay, so Giraffe, and this gets back to my recycling thing, the thing I really respected about Giraffe, and I'm glad people are doing all sorts of different things in the web server space, and this is one of many experiments, but the reason it worked for us and why it sort of appealed to me is that it's not really trying to attempt to solve the whole web server problem. And I wrote a web server. I've got my own library. You should not use it if you haven't used it already. You should use Giraffe instead. If you're using it, it's fine. We'll still support it, don't worry. Giraffe is just a really thin wrapper around ASP.NET. So it's really just trying to make it F# friendly, but it's not trying to re-engineer the entire web stack. This is Dustin Morris Gorski's project, and I really respected that. It's like, okay, we are not going to be the best people at writing a web server no matter how hard we try. A lot of people have worked on this. I was a bit wary of ASP.NET because I last tried it maybe 10 years ago, and back then it was really difficult to run on a Linux machine. And basically, when they rewrote it for .NET Core, they really cleaned it up. It's open source. And I think it officially runs faster on Linux now than it does on any other platform because it's mainly tuned to be deployed in clouds. So it's easy to get started with Giraffe. It's very easy to add more stuff. Where it does have okay server-side rendering, we're basically using it as a glorified function call. So you can just call the web server when you want something. And this doesn't matter to us at all, but it's very fast. They do pay attention to benchmarks. And I think of benchmarks as, yes, you can show off how fast your tool is, but it doesn't mean you're actually paying attention and thinking about quality and performance and stuff like that. So it's a good proxy. And it's built on top of .NET Core. And I've just been stunned with what a good job Microsoft has done with .NET Core. And this is basically when they released .NET Core 2.1 onto Bing. And this is their, basically their latency goes from, this is a distribution, so it's going from, I think, roughly 90% at the top there down to 60%. So just moving to that new runtime is enough to drop the load on all of their servers quite dramatically. This is from the Golang community. They actually went out and benchmarked all of the AWS Lambda code. And this is sort of a what the fuck kind of post. Observation 1, .NET Core is better than anything we're running. And then they get into sort of really misery as you go down to the page about the size of the Golang runtimes and a bunch of other things. But the F# functions were the fastest on that platform. Again, not going to make a big difference. For our platform, risk is we're doing so many kind of crazy things. Adding one more kind of crazy technology is probably the last thing we want to do. But it's nice to know that the stuff is actually just running really well, and there's a whole bunch of teams out there making it run even better. This is from the Giraffe project, but that's what a minimal web page looks like. The stuff at the bottom is mainly just the
the startup for any ASP.NET, and then you've got a bunch of stuff you inject to get Giraffe working, and this is really the core of your website up here. You're just saying, you know, when /ping is called, I want to run this function. And they use crazy terms like dependency injection, which, you know, I got into the FSharp community to get away from dependency injection. Makes me a tiny little bit nervous to think that somebody is injecting dependencies underneath me, but in practice it just works and you don't have to deal with it. And I guess that's sort of my mature points, like they can do whatever they like as long as it works and I don't have to deal with it, and that's what Giraffe is basically giving you. This is what our real endpoints look like. Write them down if you're trying to hack into our website. You'll love this stuff. And again, we're trying to reduce it to a really, pretty much a glorified function call. So if you hit API GSL editor, I just want you to run that function. There's a couple more exotic things here where we want to control some contents of the download. The entire thing is wrapped in a security layer. So it's very, very easy to add another function. It'll take you 2 seconds. And this is where I want to talk about our next journey, which is error handling. If you want to, this is more in the war story category, but I'm going to go back a little bit and date myself. But when I first started programming, this was a really respectable error code. In fact, in C, basically, if you got a positive integer, it was probably a file handle. If you got 0, not sure. If you got negative number, it was probably an error message, and that was all you ever needed to deal with. And I remember feeling really smug when I became a Python programmer, because now I could return 2 things. You know, that was like technology unheard of. In the C function, you were probably passing something out through a pointer that was passed in as an argument to your function. But Python, you could have a tuple. So you could have an error code and the return value. So life was pretty good, but that rapidly became unsatisfying because you really didn't know why you got an error message. So of course, if you've got a tuple, you can have a tuple of tuples. So you can return an error message as well. So now you're rocking. You've got your result, you've got your error code, and you've got a reason explaining for it. Then you get to FSharp, and you're like, we got options. And it's so tempting when you first start programming in FSharp to say none. You know, that's all you really need. You either got some result or you got none. Like, what else would you want to know? Well, pretty soon you augment none because you needed the error message as well because you want to know why you got a none. The great thing about Python is if you don't return anything, you get none. So it returns even if you didn't intend to return anything. Of course, you start to feel pretty stupid if you use options for error handling because you're saying, I've got some result, and then you've still got to produce this error code, and so you start saying, okay, or it worked, and then you find downstream somebody's actually string matching on that okay to see if your function return. You've been there, see, you've written the same code. And then you've hit the big time and you discover, I'm not going to say the word, but you discover another framework for thinking about this, which is the result type, and you just do a discriminated union. And now it's really good because you've got these 2 separate types. You've got a failure, which is, you know, because you feel pretty stupid also making up data to return. And a lot of these scenarios, like you have to return an empty record even though everything failed because you've got to be type safe. This enables you to have either a success type, which has your return value, 1, 2, 3, 4, or a failure. And then you can chain these together with operators and stuff like that. Life's pretty good. There's really not much to worry about except for warnings. Well, it succeeded, but I still want the message about what, you know, like, hey, you probably shouldn't use that piece of DNA, even though it did technically succeed. And so you augment your success type, and your success type now has some data, and it also has a message in case you've got a warning, and then failure is still just a string. Well, you're not really happy with just strings for failure because there's a lot of different types of ways things fail in life. So really, failure should be a proper first-class type, a discriminated union with a whole bunch of examples, and so you give it a proper error type. So now you've got it made. You've got error types, you've got warnings, you've got success, what's not to like. And basically, this is sort of where we ended up a few months ago, and then I'll tell you what happened next. These are sort of basically you can have different types of errors. You can make these as exotic as you like. You can have this piece of DNA will never work error if that's what your domain demands. And then if you're actually succeeding, you've got your data type for success. And it turns out if you're going to do warning, you may as well do warnings, plural. So this becomes a list of warnings. Life's great. And this is sort of basically what it looks like. So now you've got your route, somebody lands on your endpoint, you've got some horrible piece of glue, but you only had to write this once. It turns an innocent function into something that the Giraffe can process. Life's good. And success is pretty simple. here's just the example data structure we're trying to construct, and you just have a function saying we succeeded, and that does all of the wrapping and everything, so life's good. If it fails, same deal. Now we can name the type of the error, we can put some descriptions, then we fail. And this is basically succeed with warning, so you've got your okay, and then your warning. This is really great, and then you get a phone call, and it's the Internet Engineering Task Force on line 1. And they say there's RFC 7807 and you're not in compliance. So it turns out you've been passing everything back and forth with error code status 200, right? Because it's just data. And some of your calls succeeded and some of them failed. And according to the Engineering Task Force, you're supposed to actually produce something that a random web client would interpret correctly. And they've got an RFC. And so this is where things get really interesting because they want to know the status of your error, and you're basically designed a piece of DNA that's likely not to bind some other piece of DNA. And they say, sure, we've got an error code for that, that's forbidden. It's 403. And so you map all of your internal error domains onto their world, and then you provide a nice little bit of JSON that they can consume. And so sort of basically our last wrapper is to take our internal error handling world and produce something that's web compliant as it passes through the web server. So all of this is just a way of saying, think about error handling when you're building your app, and it's probably better to err on the more complicated side. It means your final functions, you see these signatures are starting to get pretty gory here. So you've got a result, which can either be an example or an error. In this case, there's no error, so we don't have a type there. Ours is success. That's the result that unifies the error and the non-error. And then we've also made it async because we could be doing database operations. Okay, life's good. And you should totally go and check out Scott's talk on railroad-oriented programming on FSharp for fun and profit. This basically talks about what happens on the client side and the web side when you're chaining all of these things together. Our other big investment for the year was Postgres. I think this is the one area where there's a bunch of type providers out there. Some of them work with many databases, some work with one. I had a shitty wrapper around Postgres that I'd used for many years, and we decided to port Dimitri's SQL provider over to Postgres. Dimitri had some polite conversations with the Postgres community about their drivers, which don't return enough type information to actually establish the type signature, and they're like, yeah. I really didn't expect this. I really expected them to just politely go and tell us to get lost. But they said, yeah, no, you got a point. We're going to actually extend the driver for you. And so for a while, we were operating on a somewhat experimental branch, but they've actually released all of that stuff. And you really should go and just check out the code. It's available on our GitHub. And basically, the concept is you write SQL the way you would want to write SQL, and the type provider it'll actually... It knows there's basically a design time connection, which is the database you're designing against, and a runtime connection, which is the one you're running. And it will tell you in IntelliSense if your SQL's wrong, if your types are wrong, if your schema doesn't match your code, it'll basically check this out. And then your results are all type safe. So all the values that come back from here match the schema. There are some corner cases where Postgres actually can't determine the type of one of its own columns, and it'll say something's nullable when it isn't nullable, but most of the time it's basically right. And you can do insanely complicated SQL and it will still work out all of the return types for you. So we're happy to help anybody use this if they're curious. I need to keep on moving. Okay, Fable. I've talked mostly of what I want to say about Fable. I think there's going to be a really nice talk by Alfonso this afternoon. As I said, the nicest thing I can say about Fable is that I've never had to look at the JavaScript and it just works. I sometimes open the console in Chrome and you see the FSharp there and you just think, why does this work? It shouldn't work. And yet, it's basically enabling me to not think about a whole different domain. We use the same data definitions on the server side and on the client side. You can use the exact same data structures. There's no sort of faking it or sort of slight skew between how it's represented in JavaScript. It just works, so we don't think about it. You probably heard a little bit about Elmish. Elmish is also a really nice framework for thinking about a website. This made me, I can actually credit FSharp with rekindling my interest in programming over a decade ago. I think I'd actually credit Elmish with rekindling my enthusiasm for writing user interfaces. The idea is very simple. You have a model of the data that should be on your website. You have a view that can draw it, given the data, and then you just have an update that changes the state. It's the way user interfaces should work. And then the Elm model basically sort of ties those three things together. And when it came over to the FSharp community, they ished it. So it's Elm-ish. It's sort of in the spirit of Elm. It's obviously not Elm. And Garrett, who's one of our developers, ished it one more time. So we're running Elm-ish-ish. And there's a brief description of what we did to it down there. You probably should seek out Garrett to get the details, but basically there's areas where, for example, we have a JavaScript plugin like the Monaco editor, and sometimes you just want to poke it, or you want it to wire it up with a dispatcher that can feed stuff back into Elmish, and it turns out to be a lot easier if you have extra handles lying around. So I think in the interest of time, I'll skip the details on that, but basically this is sort of a typical example down the bottom here where we're actually rendering something directly. We're cheating a little bit and telling it to render itself inside the update module. And then we can actually get the update module to call us back when that component is finished rendering and put signals back into the Elmish queue. That's how you wrap native JavaScript components. And this is sort of what the final product looks like. So we've got the Monaco editor working in the middle of the environment, and then Elmish is controlling all of the state and all the interaction with the server. So you end up with fairly reliable user interfaces, and your users aren't going to go crazy because some JavaScript piece loaded before some other piece loaded. Elmish really does force you to think about statefulness in your websites, which is most of the reason your pizza ordering website breaks when you type too fast in one button when some other JavaScript package hasn't loaded. That's just what the view layer looks like, so you're just using functions to emit all of the components. Nice thing about this is it's sort of one less technology you have to think about. If you've got primarily FSharp developers, they'll go into this and they can actually understand what the rendering language is. If you want to render really complicated things, so here we have a map, we're actually just using FSharp to generate a whole bunch of the website. So there's no special templating language you need to learn, it's just FSharp. Okay, I'm not going to put this under things we liked, things we survived. The cloud providers. Deployment is easy, it really is. That file on the left is actually a really complicated version of the Google Cloud Platform deploy system. You don't even need half of that. If you've built an ASP.NET project and you've published it, you can just drop that in, type the right thing, and you'll have it up on Google Cloud Platform in about 15 minutes. That's the good news. I'm not going to badmouth any particular experience because I think all of these technologies are appropriate under different circumstances, but the thing to think about is you. I would look at the quality of the documentation for the features you're going to use. Make sure the documentation you're reading is not some employee blog on a weekend that they wrote in their spare time that's out of date, but it's high quality. Make sure there's a .NET example. If you're a small team, make sure you know somebody you can call if there's a problem. And then there's sort of different degrees of control. The Google and the Azure platforms are really platform as a service. You write your code, you drop a file in, they'll deploy it. AWS is more like taking an engineering certification. You know, you're playing with the security permissions on bits on the network drivers, but if you like control, that's probably what you should be able to do. I'd say actually the nastiest surprise was probably that security is really, really complicated. I think I naively went into this thinking the cloud providers would have well thought out solutions for this, and was really quite surprised they didn't. You can see this is a stack. We spent a lot of time on Stack Overflow, and the guys at Google were very, very helpful, but you can see the reply. Until 5 minutes ago, this was nearly impossible to figure out, and they figured it out because we bugged them and worked with them. So conclusions, rich type-safe languages are good. You can use FSharp full stack, and we're still standing, right? I'm here, that's the nicest, I can say that. I haven't had too many. The things that were hard weren't the things we thought they would be, and it certainly wasn't Fable or getting it to work full stack. Reuse code, if you're thinking about contributing or writing some new open source, go and just write some docs for an existing project, and we'll pull a bug and fix it. Dugnad. Set one up in your local chapter of FSharp. It really is a great way to improve the world. Type providers are good. Think carefully about your choice of cloud platforms. Cloud security is a surprising pain in the ass. A lot of the demos, basically, if you want to make a page available to the world, it's really easy, and if you want to make it just for yourself, it's pretty easy. If you want to make it available for some of the world, it's actually where integrating it into your own authentication is actually pretty hard. .NET Core is awesome, and we have a wonderful group of people, including all of you. I'm sure many ways I've interacted with a huge number of people at this conference, and just helps and threads and support, and that's still the best thing about the language. So thank you. Okay, I am here for the rest of the day. No plans to go anywhere, so if any of this is interesting, just grab me and I'd be happy to talk in gory detail about what we did. Thanks.